The fascinating ability of hummingbirds to swiftly shift their mental gears while in flight highlights their need for speed. Greetings and salutations to everyone. In today's video, we will be delving into the fascinating subject of how hummingbirds employ two distinct sensory strategies to control their flight. This groundbreaking research conducted by the University of British Columbia has shed light on the different approaches these remarkable creatures take when hovering versus when they are in forward motion. During forward flight, hummingbirds utilize an internal forward model to accurately assess their speed. However, when hovering or encountering situations that necessitate a change in altitude, they rely more heavily on real-time visual feedback from their surroundings. These findings have significant implications for the development of navigation systems in future autonomous flying and hovering vehicles. Without any further delay, let us dive into our discussion. University of British Columbia, UBC zoologists have discovered that hummingbirds employ two different sensory strategies to navigate their flight, depending on whether they are hovering or moving forward, as revealed by recent research. Dr. Vikram B. Baliga, the primary author of a recent study on the movement of hummingbirds published in Proceedings of the Royal Society B, explains that during forward flight, these tiny birds depend on an internal forward model, a sort of instinctual autopilot, to assess their speed. The abundance of sensory input from their environment makes it impractical to solely rely on visual cues. However, when it comes to hovering or addressing cues that may necessitate an adjustment in altitude, their reliance on real-time, direct visual feedback from the surrounding environment becomes much more apparent. Not only do the findings shed light on the way in which small, nimble birds perceive their surroundings while transitioning in flight, but they also have the potential to influence the development of navigation systems for future autonomous flying and hovering vehicles, a device used to record the flight patterns of hummingbirds. In order to study the response of hummingbirds to different visual stimuli, the researchers conducted a series of flights in a 4-meter tunnel. The birds were trained to fly from a perch to a feeder, while patterns were projected onto the walls of the chamber. Every flight was recorded on video for analysis. To simulate different levels of forward movement, the researchers utilized vertical stripes that moved at different velocities along the side walls. Similarly, to imitate changes in altitude, horizontal stripes were projected on the side walls. On the front wall, rotating swirls were displayed, strategically crafted to give the perception of a shift in position. According to Dr. Baliga, if the birds were solely responding to visual cues, we would anticipate them to modify their speed in accordance with the vertical stripes on the side walls. However, although the birds did alter their velocity or come to a halt based on the patterns, there was no clear correlation. In contrast, the hummingbirds exhibited a greater ability to respond directly to signals indicating a shift in altitude while in flight. Additionally, when hovering, the birds displayed a heightened capability to precisely align themselves with the dynamic spirals projected by the research team onto the front wall. Dr. Doug Altshuler, the senior author of the paper, explains that their research aimed to explore the mechanisms behind hummingbirds' flight speed regulation. However, during the experiments, they made an unexpected discovery. Hummingbirds would occasionally pause mid-flight to hover. This led them to uncover two distinct strategies that the hummingbirds employ to control different aspects of their flight paths. To support our channel's growth and ensure broader awareness, kindly hit the like and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.